Hi my dear children, today we are going to discuss third part of that reflection of light on curved surfaces. So in previous two parts we discussed about the what is reflection and how the reflection happened in the curved mirrors and what is meant by curved mirror and what is how many types of the curved mirrors are there. So this is in first part. In second part we discussed about ray diagrams and we discussed about the two mirrors uses. So already I hope children already you have seen the videos and I think you made a notes also about that lessons. If the children who are not watch the videos, please go and watch and I hope you understand the topics and try to make notes, then you will get perfect information about your lesson. Now let's start our topic in the last part. This is the last part my dear children. Don't skip these topics and don't skip the video also, because these topics also very useful for your examination purpose. So try to watch complete video without skip. Let's start now. So as in previous class we discussed about the ray diagrams. By the ray diagrams we understand that so how the incident rays are passing and where the reflected rays are passing. So by the how the incident ray is passing and by that how the reflected ray is passing we discussed in previous classes. So whatever it is, finally we want image. So these images, where we are getting these images. So I think people, my dear students, you know that so where all reflected rays are meeting, there we are getting images. Fine, that's good. We already discussed it. Now let us see here, one more important topic is here. So here we need to discuss about object position, where we are keeping that object and on which location we are getting images. We discussed about that now. My dear children, I will explain to you. Listen carefully. Now let's see image formation. So already as we discussed, so this is a curved mirror. This is pole, this is center of curvature. This is pole, this is focus, this is center of curvature. These are the points. Listen, this is curved mirror, concave mirror. Here I am explaining with using of concave mirror. This is a concave mirror pole, focus and center of curvature. Now let's see. First, if the object is at infinity, means it is in somewhere, we don't know exact location. If the object is at infinity, then we people will get images on the focus. Image at the focus we will get. Next, and here we people will get highly dimensioned point size image. Highly dimensioned point size image. And that is also real. Next, if the object is beyond the center of curvature, if the object is beyond the center of curvature, the image is, we get image between the focus and center of curvature. Between the focus and center of curvature. Next, if the object is at the center of curvature, we will get image also on the center of curvature. Next, if the object between the center of curvature and focus, we will get image beyond the center of curvature. Next, if object, we will get object at focus, image at infinity. If the object, we will keep object between the pole and focus, you will get image behind the mirror. So once again I am repeating you, so don't get confused. Okay, I will clear that. Let's see. First point, first position is, if object at infinity, means it is in somewhere, we don't know exact location. If object at infinity, image at focus, image on at focus, image on focus, object at infinity, image at focus. Next, object beyond the center of curvature, object is beyond the center of curvature. Okay, so image between the focus and center of curvature. Second, object beyond the C, center of curvature, image between F and C. Okay, between F and C. Next, object at between F and C, object is between F and C, object between F and C. Then image beyond the C, image beyond C. Okay, object at F means focus, object at F, focus, image at infinity. Next, object between pole and focus, image behind the mirror. Okay, student, don't get confused, I will clear. Okay, simple thing is, you just remember, when object is moving towards the pole, vice versa, image also moving away from the pole. Listen this point, very important point, very important point. Object is moving where? Object is moving towards the pole. Simultaneously, in the same way, image is moving away from the pole. Okay, listen, remember this point. Now I am telling, object at infinity means it is in somewhere. See here, very far distance, it is in somewhere. Object at infinity, image on focus, image at focus. Okay, next, object beyond the center of curvature. Observe this. So in first situation, object is in somewhere, means at infinity place. So in second situation, object beyond the center of curvature means it is moving towards the pole side, towards the mirror side. Okay, so if here object at second point, object beyond the center of curvature, image between the focus and center of curvature, image is between the focus and center of curvature, means here image is moving. See here, image in first situation, image is at focus. In second situation, image at between the focus and center of curvature, means here image is moving away from the mirror. Next, in third situation, object at between the focus and center of curvature, means object is moving like here, object is at between the focus and center of curvature. Okay, next image beyond the C, means beyond the center of curvature. See here, image is moving, image is beyond the center of curvature. Next, object at focus is here, object is here now, object at focus, image at infinity, image is at infinity, it is moving. Okay, next, object at P and F, means here nearer to mirror, object between the pole and focus, image is behind the mirror. Once again I am repeating, the main point is when object is moving towards the mirror, simultaneously image moving away from the mirror. Okay, so listen this point, then you can understand. Okay, now that is the object position and image formation. So the image formation by concave mirror at different positions we discussed just now. Now let us see sign conventions. Sign conventions means, what is the meaning of sign conventions and what are the uses of these sign conventions? Let's see. Sign conventions means, here these sign conventions tells us how we need to keep mirror and where we are getting images and the rules we are getting by this sign conventions. Let's see. First point. So first point is the principal axis of the mirror is taken x-axis. Okay, so the object always placed left side of the mirror only. So see here, my dear children, observe our previous videos. I explained every time I kept object left side of the mirror only. Okay, so object placed left side on the mirror, that implies the light from the object falls on the mirror. Okay, left hand side. Next, all the distance parallel principal axis measured from the pole only. Second point. So all the distances you have to measure from the pole only. My dear children, observe our part 1 video about this lesson. There I explained you some definitions, focus, center of curvature, like that. So there I told you the distance between pole to focus, that is called focal length, and the distance between pole to center of curvature, that is called radius of curvature. I told you. Okay, so means this is the second point of signs and conventions. Second one is we have to measure every measurement from the pole only. Okay, next, third one, all the distances measured to the right, all the distances measured to the right of the origin. Okay, all the distances measured to the right of the origin. Okay, next, distances if that are taken as a positive and left side we have to take in negative, means all the distances which you are taking right side, those are positives, and which we are taking left side of the distances, those are negative. Okay, next, distance measured, the distance measured perpendicular above the principal axis, that is positive, and below the principal axis, that is negative. Once again I am repeating you the measurements which you are taking. See here, in previous class you just observe the images, the objects I kept. Okay, so those are in above the principal axis. The measurements which you are taking above the principal axis, those are positive values, and which you are taking below the principal axis, those are negative. Okay, this is about sign conventions. Okay, so my dear children, please make a notes, then you will get Okay. Next, mirror formula. Mirror formula is, so here these mirror formula, the distance of object from pole, that is called object distance, that is denoted by U, and the distance of image from the pole, that is called image distance, that is denoted by V. Okay. So once again I am repeating you, the distance between pole to object, that is object distance, that is denoted by small u, and the distance between pole to image, that is called image distance, that is denoted by V. As we know, the distance between pole to focus, that is called focal length, that is denoted by small f. Now we have to write among all these three, the relation among all these three, let us write, that is nothing but mirror formula. Let's see that. See here, my dear children, this is mirror formula. 1 by f is equal to 1 by u plus 1 by v. This is mirror formula. Here f is nothing but focal length. Focal length is nothing but the distance between pole to focus. Here u is nothing but object distance. Object distance is nothing but the distance between pole to object. Here v is nothing but image distance, that is nothing but pole to image. This is the relation among u, v and f. Okay, 1 by f equal to 1 by u plus 1 by v. Here f is focal length, u is object distance, v is image distance. Okay, this is mirror formula. Okay, this is about mirror formula. Now the last topic of your lesson reflection, that is magnification. So magnification, what is meaning of magnification? Let's see. Okay, so magnification in the sense, here magnification expressed the image extends by the object size. See here, sometimes some people will use some magnifying glass. Why? Because they can't able to see the letters. So that's why they used that magnifying glasses. So that magnified glasses, what is the duty of that? So they extend the image size. So by that the people can see who are suffered from that problem. Okay. So these magnification, this is those glasses are called magnified glasses. Now our topic is magnification. So magnification, what is the meaning of magnification? Magnification in the sense where, what is the use? Means it is extending the image. Okay, so that is called magnification. Now what is the formula of magnification? Means magnification is nothing but height of the image by height of the object. Height of the image by height of the object. This is magnification formula. Okay, height of the image by height of the object means, and we have one more formula also by that is u and v. What is meaning of u and v? Object distance and image distance. Okay, so by using that also we have one more formula, that is magnification m equal to v by u, means image distance by object distance. Let us see once again. This is magnification formula, height of image by height of object. Magnification is nothing but height of image by height of object. This is the formula of magnification. M equal to h dash by h. H dash in the sense height of image, h in the sense height of object. Okay, so this is, and these are the object distance and image distance, v by u. Magnification equal image distance by object distance. Okay, this is magnification. Understand? Okay, my dear children, this is your lesson reflection of light on curved surfaces. I hope children you understand very well, and while you watching these videos, please make a notes. By that you will get perfect information. My dear children, next time we will meet one more lesson with one more lesson. So if you understand my lesson, so please like, share and subscribe Srikar Tuitions. Bye children, take care.